So we were discussing about thermochemical conversion. So the thermochemical reaction that converts the organic biomass into more valuable and convenient form of products such as gaseous and liquid fuels, residue and byproducts, etc. So there is a thermochemical reaction that is converting biomass into we can say convenient form of product, or it can be a gaseous form, it can be a liquid fuel, it can be residue, and it can be the byproduct also. These processes can be carried out in the following ways. There are two processes basically that it can be done in the way, that is gasification and pyrolysis. So what is gasification? Now gasification takes place by heating the biomass with a limited oxygen and air, that is deficient, it is heated in when there is a deficient of oxygen and air, that is to produce low heating value gas. So what are we are getting out of this? We are getting out of this the low heating value gas, and this is by reacting it with steam and oxygen at high pressure and temperature. So then we are reacting it with your low heating value of gas. It is being reacted with the steam and oxygen at high pressure and temperature, and that will be producing the gases such as your hydrogen, carbon monoxide, methane, and nitrogen gases. So we are basically we are doing the gasification process with a combination of, that is, firstly we are heating the biomass in a deficient environment of air and oxygen, and after that we are making it to produce a low heating value of gas, and that is after that it is being reacted with steam and oxygen, that is at high pressure and temperature. Clear? And then after that we are getting out with the the gases, that is your hydrogen, carbon monoxide, and methane and nitrogen for this purpose. So this is the layout for the process. The first one is feed handling. So if we see, let's enlarge it. So see, first one is feed handling. So this is the feed material and the receiving, storage and conveying the household waste, industrial waste, biomass, pet coke. We can say all of the residues or the waste that are, or we can it can be the form of your industrial waste, it can be the household waste, yes, or it can be the biomass sources, like it can be straw, sugarcane bagasse, it can be anything that is fed to this, that is the feed material, the receiving, storage or conveying. So we have variety of feedstocks that is having a low cost. After that, it enters the second phase, that is plasma gasification. So when see, it is going through a hopper-like purpose, that is a gasifier. So it is going into the gasification, that is a plasma torches is being provided at the bottom of this. So when out of this, we are getting it. So this is we are it is we can say conveyed to the plasma gasification after this process, and this is a flexible process gasifier, and then it is being transferred onto the air, and oxygen is being transferred, and the plasma torches are given to this that we are talking of. We are just the plasma torches, and the deficient of air or oxygen is being given in this purpose. Then it is being the your covered material getting out of this, then we getting to quench it, so it is being quenched in this purpose, and it goes to the next chimney, that is a particulate removal out of this. So it is we are getting out of this, and finally we are getting out of it the steam, ethanol, power, and spy gas. So we are getting all of this, so we are getting we can say wide variety of feedstocks can be used in this purpose. Plus, out of this, we are also getting wide variety of products also. Like we are getting steam out of it, we are getting ethanol out of it, we can generate power out of it to the steam in this gas. Yes. So all these things, we can say gases are being produced just by the gasifier, and then first they are treated in the air oxygen, then they are quenched into this, and thirdly we are getting a low heating value gas, and then these particulates are removed in the final stage of out of it, and we are getting it out of this. We are getting a mass product variety, or we can say the wide variety of products being produced that have the high value of this. So starting from this, we are starting from feed materials, yes, and after this, we can say after the process of gasification, after the process of quenching, after the process of particulate removal, we are getting out of it the final, we can say, wide products, a variety of products that is can be used for your biomass production in this purpose. So the facility exports 80% of the energy input to syngas. Then plasma torches uses 2 to 5% of the energy input. So the plasma torches that is providing plasma energy to the Gasifier in this purpose is giving 2 to 5% of the energy input it is taking out. It is using that energy. Gases is not in Gasification is not incineration. So gasification and incineration are different processes. We cannot can they combine both these processes. So gasification creates hydrogen and carbon monoxide as energy rich gas stream. Yeah. So it creates hydrogen and carbon monoxide and energy rich gas stream. So energy rich gas stream we are getting out of it. So that is we are going for that purpose. Now next is your pyrolysis. So it is the heating of biomass in a closed vessel at a temperature in the range of
Hello.
it is heating of biomass in a closed vessel at temperature in the range of 500 to 900 degrees Celsius in absence of oxygen and air with the or with the steam. It produces solid, liquid, and gases. So pyrolysis is something similar to gasification. It is also the heating the biomass. We are heating it in a closed vessel, and the temperature range. The difference between the we can say gasification and the pyrolysis is the range of temperature plus it is done in the absence of oxygen and air. Firstly, it was done in deficit of your oxygen and air. It is done in the absence of oxygen and air plus the temperature range that we are working on this purpose is 500 to 900 degrees Celsius. Clear? So this purpose or it is with steam, it produces solid, liquid, and gases for this purpose. So we are getting solids out of this, we are getting liquids out of this, we are getting gases out of this. The pyrolysis process can use all type of organic materials, including plastics and rubbers. So pyrolysis process, we use all of the organic matter here. It can be plastics, it can be rubber, it can be your gas, it can be your we can say sugarcane straw, it can be rice husk, it can be any sort of waste that we can use. We can use even plastics for this purpose and we can use even rubber for this purpose. So it has a wide variety of the inputs that it can be served upon this purpose. Plus, because it is being done in the absence of oxygen and air, so it has a better value, calorific value has been increased in that purpose. So what is pyrolysis? It is decomposing of biomass that is fresh or fossil. It can be the fresh biomass. Fresh biomass comes in the category of your sugarcane, your rice husk, sugarcane bagasse, clear, or we can say household waste. We can out of this we are getting so it can be fresh or the fossil one. Fossil one can also be like they are when they are stored in this purpose that can be the fossil biomass fossil fuel by the heat of anaerobic. Clear? Anaerobic means reduced air in this purpose. Aerobic and anaerobic basically the heating the anaerobic reduced air combustion, which converts organic material into gases or fuel oil. So we reduce it is being combustion is done that is converting the organic material into gases or fuel oil. So we are converting in the process of pyrolysis the organic materials that we are getting out of it that can be fresh or fossil they are converted into the gases or fuel oil. So they can be used for in the form of gases. The gases can be served for the purpose or fuel oils that can be used directly or indirectly for the heating purposes or that can be transported to the longer areas. So in first we see the biomass, it is being served into this purpose that is tar and charcoal getting out of it. And above of this we are getting the we can say the fuel is being served in this purpose. The gases out of it is being escaped from the first column to second column out of this and at the bottom of the first one we are getting tar and charcoal that is we can say leftovers. In the second we are getting fuel oil. Fuel oil is supplied directly because the oil being we can say it comes to the lower part of this and from the lower it can be we can say supplied and then in the form of that gas that is called methanol. Basically, the methanol is being taken because gas being the lighter one, it will be going towards the top of this chamber. So when it is being striking at the top of the chamber, so it is striking the top of the chamber. Above the chamber, we are getting taking methanol out of this and we give gas out of this. So we are getting the gases out of on the top part and the fuel oil out of the bottom bottom of this, we are getting it from the openings that is provided, one at the top and one at the bottom in this purpose. So pyrolysis is all over basically the combination, or we can say pyrolysis is at part, that is we are converting the organic matter into the gases and the fuel oil, or the fuel oil. Yes, it can be only with we can produce only the gases out of it, or it can we can produce oils out of it, or we can produce gases and fuel oil also in this purpose. So that is all about the process of pyrolysis. So after this, we have biochemical conversion. In the biochemical process, the bacteria and microorganisms are used to transform the raw biomass into useful energy like methane and ethane gas. So following organic treatments are given to the biomass. So first one is fermentation of biomass, that is anaerobic digestion, then anaerobic digestion of biomass. Clear? So we are getting two processes being done in the biochemical process, the bacteria and the microorganisms that are used to transform the raw biomass into useful energy. So we are using the action of bacteria and microorganisms in this part, that is used to transform the raw biomass into the useful energy in this part. So the raw biomass from this purpose is being used for useful energy, that can be like methane and ethane gas. So we are getting organic treatments are given, that is first one is the fermentation and the second one is the anaerobic digestion of biomass. Yes. So and that is only done by the action of your bacteria and microorganisms for this purpose. So what is this all over fermentation and anaerobic digestion? These are two things. So fermentation is a process of decomposition of complex molecules. Clear? So in this part, we can say the decomposing the complex molecules out of this. So